In 1769, William Smith was born in the little village of Churchill in the south of England. His father, who was the local blacksmith, caught a chill and died when he was just 8 years old. So young William was then raised on his uncle William's farm. The lad was strong, well-built and energetic, with more than his fair share of natural curiosity and the smarts. He was already taking an interest in rocks. There were the Chedworth buns that were thrown up by the ploughs. The local dairy maids used them as weights to measure out butter. We now know that the buns were fossil E-chi-no-derms or sea urchins. He also played marbles with fossil brachiopods that the boys called pundibs. Since the time of Pythagoras, a small number of scientists had recognised that fossils were the remains of ancient living things. But many of the local stone collectors believed that fossils were like crystals, figured stones that grew naturally in the rocks. Smith would grow up to be the first to use hundreds of such fossils as true time markers in his stratigraphic column of rocks. There was plenty going on in 1769. Lieutenant James Cook, in the leaky old converted coal carrier Endeavour, was working his methodical way north towards Botany Bay. Its rich young scientist passenger, Sir Joseph Banks, would eventually become Smith's patron, financier and protector. Josiah Wedgwood, grandfather of Charles Darwin, was mining good British clay and perfecting his process to make fine Wedgwood china plates. John Iron Mad Wilkinson was building the first iron bridges and would cast the boilers for Scotsman James Watt's steam engines. The steam revolution would transform England. Our ancestors would be herded from little rented farmhouses in the countryside to toil in the quarries, coal pits, cotton mills and metal foundries of the British Industrial Revolution. And what powered that revolution were steam engines, and the ideas and ingenuity of the scientists, inventors and engineers of the British Royal Society. Britain is a wet country, and it was inevitable that it would build a system of canals to transport its heavy goods around the country and to the ports for export. Eventually rail lines would be built next to the canals. The canals needed clever engineering and hard labour. They had to be narrow so that horses could pull the barges from paths on either side. The tunnels were a nightmare for the bargees, who had to push with their feet against the tunnel roofs. There were aqueducts across rivers and complex locks to repeatedly adjust the water levels. In 1787, at the age of 18, geology mad Smith apprenticed himself to Edward Webb, a surveyor. He was soon expert in the latest surveying tools, including big chains, pantographs and the-od-o-lites. His first task in his long geological career was to survey the 3.5 kilometre Somerset Canal tunnel. Later he worked with a very capable engineer, John Rennie, in surveying the Somerset Coal Canal. Eventually Smith would branch out on his own and work for some of the most prominent people in the land, accepting commissions in searching for coal, draining swampland, building artificial sand dunes along the coast, and mapping the countryside. He was much sought after as an engineering consultant geologist, because he was the first to realise what was going on underground. Smith's underground explorations began when he rented rooms in this tenant farmer's house and began to explore some of the pits and shafts of the Somerset coalfield. They were dangerous, narrow hell holes, prone to cave-ins, flooding and methane gas explosions. The miners were little better than slaves. The new technology just allowed the mines to go deeper. Steam engines pumped water out and forced air down the tunnels to keep the miners alive. Smith went down using chains, ropes and slippery ladders, using a candle to look at the rock layers or strata. The miners shared their knowledge with a working class man whom they nicknamed Strata Smith. Smith was looking for a pattern. The top layers were easy and included this impure reddish magnesium limestone that we call a marl. He noted that they tilted gently to the east. Then there was a break. The underlying Carboniferous coal measure rocks were tilted. Bill had passed an unconformity erosion break like this one. Coal measures have lots of layers, much like these Permian coal measures at Newcastle, New South Wales. The Carboniferous coal seams back in Britain, made from compressed plant materials, had been given names by the miners. There was the Slyving, the Dungy Drift, and the Kingswood Toad, and dozens of others. The rocks were tilted, folded and faulted, but Smith found that the rock layers were always in the same order in each shaft. The other useful things were the fossils that he collected. Fossils were the key. They helped him to identify the layers in each shaft. Smith was always the wanderer, a man of boots. It was time to move on and explore the younger layers that should be on top of the ones that he had seen. His life's work would depend on three great principles. First came the law of superposition that applies to sedimentary rock layers and lava flows. It's common sense. The oldest rock layers are at the bottom. Occasionally the law is broken in fault mountains, but that is easy to detect. Second is the principle of stratigraphic correlation. This is best shown in this U-shaped glacier-gouged valley in the north of England. The rock layers can be traced across or correlated across the valley. Third was Smith's major gift to geology. Fossils helped to identify the strata. So not only did he describe the rock layers and their uses in some detail, but he published coloured drawings of the fossils that they contained. In 1801, Smith set himself the task of mapping the whole of Britain so that he could publish a detailed geological map and commentary. He would finally publish the masterpiece in 1815. In between his consultancy jobs for the nobility, he walked tens of thousands of miles to map 50,000 square miles of terrain. He was positively scary. An energetic, talkative, hyperactive bull of a man, travelling by coaches and charging off into the countryside with his big hat, lots of maps, a bag of rocks, a hammer, and a bottle of acid to test for the presence of limestone. He stayed at inns and became well known for his storytelling to people the length and breadth of the country. The final publication was Smith's Triumph. The costly printing plates were personally coloured by himself and his nephew, John Phillips. The map was 2 metres wide by 3 metres high and had to be sold in 15 sections. The book contained coloured fossil plates and a detailed description of each rock layer. 400 copies were produced to sell at £7 each. The Duke of Norfolk presented him with a prize of £52. But there were just 2 problems. Smith had huge debts, and there was a depression on as the whole country had to pay for its war against the dictator Napoleon. The maps were not selling as expected. Smith was forced to dispose of assets, including his huge fossil collection that had cost him so much to house. In 1819 he was thrown into the Queen's Bench debtors' prison, paying full board and lodging as his assets were sold off. Finally, after 3 months' incarceration, and with the help of Sir Joseph Banks, he was set free, and with little in the way of money or possessions, took the coach north. He was quite bitter, but his fortune would eventually change. He was far too useful to the interested miners and aristocrats of Yorkshire, who would accept him as one of their own. His nephew John Phillips would become a celebrated geologist himself, as Professor of Geology at King's College London, amongst a host of other honours and positions. But let us look at what Smith had achieved and where it would lead. His collection of 2,600 fossils, together with those collected by Mary Anning, would inspire an interest in paleontology by scientists all over Europe. His column of rocks was correct, even if his names were rather odd. It would become the stratigraphic column that we use today, and would form the basis for the geologic timescale when modern methods for dating rocks were to become available. Just as poor old Smith was stuck in jail, a new breed of younger geologists arrived to build on his work. Some would travel overseas and compare the British successions with those in other countries. Layers would be renamed and the column divided into eras, periods and epochs. We will start with the youngest rocks at the top of Smith's sequence. The youngest geological era is the Cenozoic, which means new life. Smith's Cenozoic rocks are shown in yellow on this map. They include some clay and sandstone strata, plus some younger sands containing lots of shells. Most of them were formed in the Eocene epoch of the Tertiary geological period. Lyell and Murchison visited European geologists and studied their rock layers and loose sediments around river estuaries and on floodplains. It was agreed to divide the Cenozoic into 2 geologic periods. The older Tertiary period with 5 epochs, and the younger Quaternary period with just 2 epochs. Man, his ancestors and their stone tools are found in Quaternary sediments. it would be interesting to look at the experience of Australia at the beginning of the Cenozoic. It had spent much of its geologic history being welded to Antarctica and to New Zealand. These had separated. Antarctica headed south for the deep freeze. Australia was headed rapidly north and would dry out. Its rich Antarctic beech tree rainforests would change to grasslands and then to desert. The end of the Cretaceous and the beginning of the Tertiary was defined by a massive and sudden worldwide extinction where most animal and plant species were wiped out on land and in sea. We know by radar and gravity surveys that a meteor hit the ocean in the Gulf of Mexico. Its impact is recorded in clay layers called the KT boundary in many parts of the world, including New Zealand. These layers contain meteor elements, including iridium. Indian geologists think there were other impacts. The biggest animals fared worst. All dinosaurs, such as the Aussie Muttaburrasaurus and his marine reptile mates, the plesiosaurs and ichthyosaurs, disappeared. You'll be pleased to know that extreme climate change in the Pleistocene glacial epoch extinguished our megafauna horrors. The word Mesozoic means middle life, and the era lasted almost 200 million years. It has also been called the Age of Reptiles, particularly the dinosaurs who became bigger and scarier with time. Smith spent a lot of time exploring the Mesozoic strata which outcropped in the south of England and correlated with similar rocks throughout Europe. There are three periods: the Cretaceous, named after Creta, the Latin name for chalk. The Jurassic is named after the Jura Mountains of Europe, where Jurassic rocks are common, while the Triassic is named after a rock sequence in Germany with three prominent strata sections. The Sydney-Gunnedah-Bowen complex of sedimentary basins form a linear structure running up into Queensland. Each basin is roughly saucer-shaped, and they rest on older, fold mountain rocks of the Lachlan Fold Belt to the west and the New England Fold Belt to the east. The Sydney Basin sediments have a maximum thickness of 4,000 metres and were formed from the lower Permian to the middle of the Triassic period, when the Sydney Basin became dry land. These cliffs south of Sydney give you an idea of the size. The base of the cliff is the bottom of the Triassic, and the top of the cliff is the bottom of the mid-Triassic. So we are looking at just 15 million years of Earth history. At sea level at Coal Cliff, we find the top of the Permian, where the Bulli coal seam has been mined. But there is a very noticeable change in the rocks. The Permian rocks to the south are full of life. The Triassic rocks are barren, particularly the lower Triassic rocks. Life is there, but it has been seriously smashed. It is the same worldwide, Geologists call the end of the Permian the Great Dying. 70% of species on land disappeared, and in the sea up to 96%. It was the worst extinction in history and marked the beginning of the Mesozoic era. The main suspect for the Great Dying is the eruption of the biggest supervolcano in history in central Siberia. Even today, its surviving lava flows cover 2 million square kilometres of territory. Pangaea was still intact. The volcanic ash would have blocked out the sun, covered much of the supercontinent, and the sulphur dioxide gases would have acidified the ocean. Life is scarce in these British Triassic rocks and would not recover for 20 million years. Modern isotope studies provide this possible data for Mesozoic climate change. First, we look at the levels of carbon dioxide compared to those now. We conclude that the Mesozoic was quite hot, with plenty of carbon dioxide to encourage plants to recover. The second thing we look at is the levels of oxygen compared to those now. We conclude that the Earth recovered quickly and supercharged the air with oxygen for the aggressive large dinosaurs to breathe. By the mid-Triassic, recovery was well underway. This Dichroidium seed fern came from Charles near Avalon, and the last of the world's big amphibians were blundering around the swamps of Ashfield. Most reptiles had been wiped out, except for one group called the archosaurs. And this little dinosaur was the forerunner of the massive beast to come. As for our Bill Smith, he wandered around his Jurassic coast collecting lots of fossils. The squid-like ammonites were common and could get rather large. The limestones reflected a healthy Jurassic sea. The white cliffs of Dover on top were made of Cretaceous chalk. The chalk is made from calcite plates dropped by floating algae called coccoliths. This was only possible in a healthy Cretaceous sea. The dinosaurs evolved to a terrible size, becoming massive eating factories. But they were too specialised. The KT crisis wiped them out. Coincidentally, a supervolcano erupted then in India, producing the Deccan volcanic traps. So the story may not have been just a meteor. The younger rocks of the geologic column tell a tale of 3 great extinction events. The last in the Pleistocene ice ages killed the Australian megafauna and almost wiped out the humans worldwide. Much remains to be researched by our disappearing and undervalued geologists about how our planet works. The time clock is ticking as we dominate the Earth like the dinosaurs did before us. Our next video will examine the older eras of geologic time. Learning is the essence of being, so take time to enjoy it.